The other day, I was looking at the news and I was really surprised to see that Cassini was ending its mission in Saturn. In my mind, it didn't make sense because I remembered that Cassini was launched a long time ago. So it didn't make sense that thing that had been working for almost 20 years. But today, in this episode of Cosmic Kingdom, we are going to render a huge homage to this incredible feat of engineering that has given us such an awesome science. Goodbye, Cassini Huygens.
Three, two, one, and liftoff of the Cassini spacecraft on a billion-mile trek to Saturn.
So it was launched in 1997 from the Earth in a rocket, and then on top of that it was detached from the rocket, and then the thing flew. So the main instrument was called Cassini, but when they reached Saturn, they just deploy Huygens into Titan's atmosphere. Huygens was deployed in 2004 onto Titan to try to understand this satellite of Saturn. So first of all, because Saturn is so far away and you can only launch rockets at a certain speed, they had to do several what is called slingshot maneuvers, and I think it's good for another episode just explaining it. The slingshot maneuver is basically you send a spacecraft or a probe around a planet, and you use the gravitational potential of that planet to increase the speed of the probe. And at a certain point, you just fire on the rockets and you are able to escape the gravity, but you are already spinning fast. You're already having an increase in your velocity. This allows you to reach higher velocities without increasing the payload, the initial payload of the rocket. And the interesting part is that Cassini flew 2 times around Venus in 1998 and 1999, and another one around Earth in 1999. And then from 1 year it flew towards Jupiter, had another flyby, and then just head up to Saturn to study the rings of Saturn and its satellites. The interesting thing, and I was so surprised, the original mission was planning to last 4 years, from June 2004 to May 2008. It was extended for 2 more years up to September 2010, and then again extended up to today, 2017. And the reason why they have decided to crash the probe onto Saturn is really, really interesting. The scientists were worried that in some moons they might have offered habitable environments to the microbes, the Earth microbes that these probes are. Instead of all the effort they put in white rooms and stuff like that, it's very difficult to avoid any microbe. So they were worried about that. So what they did is, okay, let's throw it to Saturn. It will burn on the atmosphere, so we are not contaminating our solar system. I think that is kind of really cool. The amount of detail, the amount of thought these people put in these missions. So what are the scientific outcomes of Cassini Huygens? Let's start by the Huygens probe. As I said before, it was launched onto Titans it's a moon of Saturn in 2005. It was the first landing on the outer solar system. So we have plenty of information of this satellite line in the form of images. Also, in the flybys of Earth and Venus, we have more pictures, but I think the most impressive ones were the ones about when the probe passed close to Jupiter, and we have these amazing pictures of the atmospheric movements of the surface of Jupiter that are really, really, really important now to understand the weather in exoplanets. And then you have enough results here for just a whole season of Cosmic Kingdom. But I will try to summarize it a little bit further. So you have a lot of data from the Saturn system of satellites. A lot of data from its rings, and especially in the last flyby, because initially you don't want to risk the probe, but in the last flyby they just throw the probe through the rings. I'm sure they will have more models, more interesting things to do than that. They also find something really interesting. If you notice, the rings of Saturn have a hole inside. Not a hole, but it's like a ring with nothing inside. That is called the killer gap. Cassini was able to take a picture of the moon in that gap. And this is of crucial importance, because the way we believe the solar system, or any system with a conserved angular momentum, forget about the technical part, is that you have a disk of gas, and in certain areas of that disk, you gas and dust, you have a grain of dust that is a little bit bigger. It reaches like a small tiny amount of size, and it starts sweeping around the disk, creating this hole. We have also a lot of Enceladus flybys that is it's frozen, but there are like plumes of gas, plumes of matters going out. And I will do another episode with my friend Emily here, because she discovers some pretty cool stuff on Enceladus. It was able, and I think this is really cool, it was able to take a picture of an hexagonal structure on the north pole of Saturn, which is amazing, and it has been predicted by models, and also to study a storm in Saturn, which is called the Great Storm of 2010, and what happened after the storm. And then on top of that, you add as many flybys around the satellites, the system in Saturn, and you will see that it's amazing. And that's it. I mean, you can look, the NASA web page is amazing, and there are like more flybys, more data. So to summarize, I think Cassini-Huygens is an incredible project, because not only, I mean, it involved NASA and ESA cooperating together during 20 years to just reach the outer part of our solar system. Sometimes I'm going to get a little bit political here, because most of us know who Cristiano Ronaldo is, or I don't know, Messi or something like that. But to be honest, if I cross through the street one of the engineers of this probe, I wouldn't be able to recognize them. And it's incredible what we can do when we collaborate, when we work together, and we decide to join efforts to understand the universe. And that's all for today. I don't want to say anything more. I just keep that thought in your mind. You know who Cristiano Ronaldo is, but you don't know anyone from these people.
Rocket went up through the clouds, and it lit up the clouds, and then everybody went, oh! Because they thought something bad had happened, and then as it penetrated the clouds and came out, everybody was, oh, what a relief it did. It takes Saturn 30 years to go around the sun once, and that's almost how long I've worked on Cassini. I've seen Saturn in all of the various seasons and all of the changes that have happened over the 13 years that Cassini's been in orbit around Saturn.
I think what you're seeing here, now that the mission is ending, is the culmination of a lifetime for some people have worked on this mission, literally their whole professional lifetime. And the fact that it's been so successful and has worked so well, it's probably the most complicated interplanetary spacecraft that's ever been built, is a real acknowledgement of the people that worked on it.
It's been really hard. Counting down below 100 days, it got real. And so we're just
I'm in stage 1 of grief denial. It's a very comfortable place to be after 20 years. So.
I'm trying to get past anger.
But it's going to end the way I hope I end, quickly. You know, it's not going to die slowly, you know, and linger around. it's going to go out in a flash. It's just like that was born in a flash. So I feel good about that.
So this is it. It's time. It's time. And look at the science we're getting right now. And the engineering. This has been pretty amazing.
In a sense, Cassini's ending is also a beginning, because it makes me think we need to go back to answer the question, does Enceladus have life? What's going on in the lakes and seas on Titan? How about Saturn's atmosphere and a probe to go into Saturn? And then, of course, on to Uranus and Neptune. So as we close Cassini's chapter, there's so much left to do and explore in our solar system.